Well, guys, here we go. Yeah, again, more of some of the stuff that we're going to keep building on here in this chapter, and everything's really going to deal with triangles. Now, guys, last section we took a look at side angle, side congruency theorem. I don't want you to lose sight of that stuff because that stuff is going to resurface as we continue to move through the chapter. 12.4 is about equilateral and isosceles triangles. What we're trying to find out today, what conjectures can you make about the side lengths and angle measures of an isosceles triangle? Okay, so again, isosceles triangle, a triangle where how many sides are congruent? Two. Okay, two sides are congruent. In order to answer this question up here about the conjectures we're going to make regarding the lengths and the angles of an isosceles triangle, we need to understand what it means to use base angle theorem. And then what it also means to use isosceles and equilateral triangles interchangeably. There's going to be some theorems and some corollaries that we come up with today. There's some big words involved in this, but I think if you take a look at the explanation and compare that to the diagrams that we put up here, I think that this will make total sense to you today. Okay? All right, so here we go. We need to know some vocab. Okay? Legs in this section. Legs. Volunteer to read that definition for me.
The two congruent sides of an isosceles triangle.
Okay, two congruent sides of an isosceles triangle. So if I was going to go ahead and draw my isosceles triangle like so, you might want to go ahead and draw this in here quickly. Okay, that'll be the two congruent sides in an isosceles triangle. In that triangle that I just drew up there, which two sides appear to be the congruent sides? Which ones? Top two, left and right. So if I want to indicate that those two lengths are equal, what do we need to do to both sides? Tick mark here, tick mark there. Okay? Guys, you're going to hear the term vertex angle brought up a lot in isosceles triangle. And the vertex angle is going to be that angle that's formed by the legs of the triangle. So the legs are the two congruent sides. So if I redrew this triangle, where would the vertex of this angle lie? Okay. So if I draw my isosceles triangle again, just like so. And give me some room here. Again, if these are my two congruent sides on the left and the right, then the vertex angle is this angle right up here. That angle, that's the vertex angle. No joke, I feel like I'm making a cartoon character right now. Just saying. You see it?
Yeah. No.
The head, and then the triangle's dress, and the two tick marks for the arms. And we talked about legs of this already, right? Right?
Yes.
Okay. How about the base? How about a base of an isosceles triangle? What is that?
The one that's not the leg.
It's the one that's not the leg. It's the one side that's going to be a different length. In our isosceles triangle right here, where's my base?
Bottom.
Yep. Bottom here would be the base. It's the one side that's not equal to the others. Now, if the triangle's equilateral, any side can be the what? Any side can be the base, and the other two sides can be the legs. Okay? Guys, the last one down here, base angles. I don't like the way that they term this. We're going to go with what they have in terms of the definition. It says it's the two angles adjacent to the base of an isosceles triangle. They talk about it being opposite sometimes, opposite of the sides that are legs. Base angles are simply the angles at the what? Base, okay? So right here, guys, this angle down here would be considered a base angle. They're the two angles at the base, or they're the two angles that are adjacent to the legs and the base at the same time. Okay, so the base angles are going to be right here and right here. All right, so just a quick review on vocab, because these are going to be terms that we need to know before we can progress through this section right here. Are you okay on legs of an isosceles triangle? Are you okay on a vertex angle? That angle that those two legs form? Are we okay on what the base side is of that isosceles triangle? And then likewise, are we okay about base angles then? Okay, we've got a vertex angle and two base angles. I'm going to write this down here, and that there's two of these, and there's always one of these. In an isosceles triangle, there's going to be two legs and one base. So you may want to put that stuff in there too as well. Okay. Megs, you got the countdown on, buddy? Got the countdown on? Okay. Need anything else at all? Okay. We'll be able to get more tape. Okay. All right. Yeah, I have something I want you to look at too. Our sheets that are over there from last year and where we're at now. Okay, here we go. Guys, the core concept today is this. We're going to talk about really two theorems. One of them is called the base angles theorem, and one of them is going to be called the converse of the base angles theorem. First one, it's most important for us in this section right here, base angles theorem. How about a volunteer to read what that theorem says for me, please?
If two sides of a triangle are congruent, then the angles opposite them are congruent.
Okay, so two sides are congruent. So what kind of triangle does that make right here, guys, right off the bat? Isosceles. So I'm going to put some numbers to this. Let's affix some numbers to this. Let's suppose that if this is 12 units on the left, this is 12 units on the right, that's an isosceles triangle. Okay? Guys, the base angle theorem says if you have an isosceles triangle, two sides congruent, then the angles opposite of them are congruent. So guys, right here, here's this side of 12. Isn't this angle the one that's opposite of this 12 over here on the right? Would you guys agree with that? Let's just say then that I have this angle right down here. It says, if you have an isosceles triangle, then the angle opposite the two legs that are congruent, these angles down here are congruent down here. Basically, the angles at a base in an isosceles triangle are going to be what? Congruent, okay? Now the converse of the base angle says this. If two angles of a triangle are, what's the word here? Then the sides opposite them are congruent. Basically what this is saying is, well, let's suppose we have an isosceles triangle like this. Okay? And I'm going to change this up a bit. I'm going to rotate this a little bit, maybe draw it like that. They're simply saying the following. If the two legs are equal in length here, then what must be true about these two angles right here? Or vice versa. If these two angles are the same right here, what's that mean about this length and this length in that triangle? They are the same. Okay? They're the same. So a lot of wordiness there. I think if you just run a diagram, basically the angles are with the base and each leg that are equal. The angles that are congruent in an isosceles triangle are going to be adjacent to the base and a leg. Okay? And then the vertex angle is going to be the one oddball in all of this. Good there? All right. Well, let's move to page 2 then, if everybody has what they need. Anybody need more time with that right there? Any questions so far? Pretty straightforward right now, isn't it? Let's run through these examples here. I think I've got about 3 or 4 examples to run through. I need some help labeling some stuff, kiddos.
Got it.
All right, so it says use the base angles theorem. It says in the figure, angle A is equal to angle B, name two congruent sides. Please help me with the vertices up here. What's this? B?
No.
This is?
A. C.
All right, which two angles are congruent, kiddos?
B, C, and AC.
Okay, well, tell me the angles first. Angle B and angle A. So if I put an arc mark at B, I need to put an arc mark where?
A.
A. So if that's true right there by base angle theorem, guys, which two segments must be equal again, Hannah?
B, C, and AC.
Okay, so by base angles theorem, so I'm going to say by, watch this, I like this. Superman's not going to like it. Superman won't like that. You bet he is. Superman would destroy Batman. Who says no? He's got these things that come out of his eyes. That's all he needs.
Yeah, he would easily. So this person's saying yes.
I'm saying that Superman would destroy Batman. That's what I'm
No,
saying.
they're on like the same.
All right, this here says by base angle theorem. Okay, base angle theorem. Bruce Wayne's favorite theorem right here. Okay. By base angle theorem, which two sides again? One more time, Hannah. I've forgotten already. BC was one of them, I think.
Yep.
Congruent to what?
AC.
So if I had to affix tick marks to them, you would agree, guys, that this side would equal this side then? So the question is, given an isosceles triangle, if you're given congruent sides, can you identify the congruent base angles? Vice versa, if I give you the congruent base angles, can you identify the congruent sides? Pretty simple, right? Pretty simple. So easy a bat can do. Right? Huh? All right. Let's talk finding measures in a triangle then. Example 2. I believe down here in the bottom left I put 2x. Is that right?
Yeah. And then.
Whoops, that didn't go the way I wanted it to. How about this? And I think I have tick marks all the way around here. Is that correct? Okay. How do you know x equals 30 right off the bat?
Because all the equals are 60 and
Exactly. Exactly. Let's kind of put this together in our own words right here. The first thing you know about this triangle is what, guys? It's equilateral, which means it's also equiangular. So I'm going to write this down. I'm going to write this down. Since equilateral triangles are, how do we classify this by angles then? If it's equilateral, it's also classified by angles as, what was the word again? Parker, I think you said it once, didn't you? Equiangular, right? Since that's true, then each angle must be how many degrees in here? Then each angle must equal 60 degrees, right? So that being said, we can take the 2x and set it equal to what value, guys? Set 2x equal to what? 60. So from this, we know that x is equal to what value here then? 30 degrees. Perfect. Perfect. Well, I shouldn't say 30 degrees. I should just say x is equal to 30 there. Okay. Pretty short and to the point, isn't it? All agree? Okay. Example 3. I think if there's a difficult example, it might be right here. Okay, so I need some help with this right here. Did I give any vertice names at all? Or just lengths? And okay. If I remember correctly, I think that here was 28. Is that right?
Yeah.
This was also 28.
Yep.
What else is identified in it? Can I see yours, Maddie?
Yep.
Okay, I like this one. All the angles down here are the same. Where's your y and x at then? It's like 2x's up here.
Yeah.
And what's this thing?
4y.
Along the side?
Yep.
All right, I really like this problem. I really like this problem. Okay, let's talk on this, guys. Our job is to solve for what and what, you think? What do you think we need to solve?
X and y.
Okay, so I'm going to make a table right here. Solve for x. And then likewise down here, I want to solve for y. Okay. Okay. This isn't as easy as it looks, I don't think. Basically, guys, we have two adjacent triangles put together to form a larger triangle. Okay. Now, as I look at this right here, guys, look at the triangle on the right. What do you know about that? It's equiangular. All the angles are the. Furthermore, how many degrees are these down here then?
30.
Ooh, careful.
60.
These are all going to be 60-degree angles, right? Now, That being said, if the triangle is equiangular, it must also be what? Equilateral. So if this distance is 28 right here, then doesn't this have to be 28 right here? Doesn't this have to be 28? Okay, so right here off the bat, guys, to solve for y, you understand that if these are all the same right here, 4y has to equal what value then, guys? 28. So to solve for y, we would set just that up. 4y equals 28. And what was your y value again? You bet. That's pretty easy to do right there with the y value. Okay. Guys, the second part of this, excuse me. Second part of this is kind of an interesting deal. I'm going to highlight this right here. What's the distance from here to here in this triangle? 28, right? What's the distance from here to here? It's also 28. We found that out because this was equilateral. This was 28 here, so it makes this equilateral up here, right? Would you guys agree with that? Okay. Well, if that's true then, guys, pick a different color here. Oh, maybe yellow. What's this angle right here have to be? Whoops, I didn't want to do that. What's this angle right here have to be? Okay, this here is 60 right here, right? So doesn't that make this angle right here 120 degrees?
Yeah.
Okay, so the question becomes this. In that isosceles triangle, we agree that this is isosceles, marked off up here in red, right? You guys agree that triangle's isosceles now? Because this side is 28 and this side is 28. Guys, if 120 degrees are used up in the vertex angle, how many degrees does that leave you for the base angles? 60. But if each one of these together are the same, add up to 60, what's that mean about the measure of each angle right here then, guys? What would this have to be in terms of what two numbers same would add up to 60 degrees? 30, right? Isn't this 30 degrees here? And isn't this going to be 30 degrees up here? So we're going to set 2x equal to what? Right? Set the 2x equal to 30. Again, 30 and 30 is 60, and 120 more is 180. These have to be 30 and 30 because what type of triangle do we know this is in red now? Isosceles. And my base angles up here on the top right and the top left must equal each other. So therefore, I'm going to set the 2x equal to 30. What's that make the x value? X is 15, isn't it? Okay. Lot going on there. Lot going on there. My suggestion. Fill in everything you know. And then start working with it. We had a lot of information up there already, but do we have all the information? Were we able to attain it? Pretty easy. Okay? What questions have you got so far? How many are like, no, I feel pretty good about this right now? Pretty good about it? Okay. Well, then let's run over to this last example today, and then I'll send out a new assignment that you can get started on today.
Today or tomorrow?
Today, John, today. Remember, today's the tomorrow you worried about yesterday.
Oh, I like that.
I don't get it.
Okay, I need some help with some vertices. P, Q, R, S, and T. Guys, excuse me for a second. Thank you, John. Okay. Solving a multi-step problem. Let's take this diagram and dissect this and figure out what we know first of all. What do we know, guys? PT is equal to SR. Oh, I'm sorry, ST, right? ST. PT and ST. You guys agree that those are equal right there? Might want to get some tick marks in there. Okay, so go ahead and draw those. What else do you know? PQ RS are equal, right?
Q, well that triangle QRT, it's isosceles.
Maybe. Okay. Maybe. We'll see. We'll see.
Carson, it is.
Why?
Because there's two sides that are equal.
Okay, let's talk here, guys. This is supposed to say prove right here. How to change this. This should be not probe. That was an experiment by Ford. That was a disaster one year. The Ford probe.
Sure?
Yes? Just saying.
Just saying.
Okay, explain how to prove that triangle PQT is equal to or congruent to triangle SRT. I'm going to go ahead and highlight the two first. Is that okay? So what triangle first, guys? P to what to what? Trying to show if that triangle is congruent to what else?
R.
SRT. S to R to T. Whoa! Didn't want that to happen. Whoa! Didn't want that to happen. What the heck? See, I use the word Ford and everything falls apart up here.
Stop. Carson.
Okay. This is the other triangle. Oh, come on. Jeez, come on. Okay, those two triangles we're trying to prove congruent to each other. Here's the deal, guys. I want you to think back to the last section. What was the name of the congruence theorem for triangles? Side angle side, right? Okay. Would you guys agree that in triangle PQT and triangle SRT that we have kind of a side and a side right here?
Yeah.
And a side and a side, two pairs of sides that are congruent already, right? So the part that we need is the included angle. Okay? So if you look at these two sides, RS and ST, what angle does that make up here, guys? Angle what? What does this segment QP and PT make up? What angle does that make up? P. Do you guys agree that angles P and angles P and S are the ones that would be the included angle? Okay. Let me ask this question. Are P and S congruent? Are those two angles congruent?
Yeah.
Yes? No? Not sure? How do you know? I hear some people saying yes, angle P and angle S are equal. How do you know? Say it again, Bryce. Say it louder for me.
The two angles two lines.
Are you talking here and here?
Yeah.
So you're talking, it sounds like to me you're talking about, I'm going to do a different highlight up here, okay? Sounds to me like you're talking about the overall triangle, the great big triangle. Sounds like to me you're talking about from here to here. Oh, come on. From here to here. Guys, if you look at that big red triangle, okay, what's true about the distance from PT and ST? They're the same. Therefore, what type of triangle is my red triangle right now? Isosceles, right? With base angles at P and at S. Well, by base angle theorem, what does base angle theorem tell us about angle P and angle S if these two sides, PT and ST, are equal right here? These angles have to be what? Congruent. So if I put an arc mark at P, I have to put an arc mark where else? S. Okay? Guys, explain how to prove that PQT is equal to triangle SRT. Here it is. Here it is. You know that the side PT is congruent to the side, what? Over here in blue. PT is congruent to what? S to what? Isn't that like the side part, pair of corresponding sides part? Okay, what angles do you know are equal? Angle P is equal to angle what? Isn't that like showing the included angle right here of each triangle is congruent? And then what's the last pair of corresponding sides that are congruent to each other? What's PQ equal to, guys? Segment PQ is congruent to segment Are those congruent sides or congruent angles right there on that last one? PQ is equal to RS. Is that a side or an angle? You've just shown by, what's this theorem called again? Side angle side congruency theorem. The triangle PQT is congruent to triangle SRT. Okay, so the two triangles are the same. So the question becomes, why now is this triangle that's left in the middle, say maybe right here, why is this triangle in the middle right here? Why is that isosceles now, guys? Well, here's the deal. If the green and the blue triangle are congruent, what's that mean about the distance from QT and RT? What must be true about them? They have to be the same. So if I put 3 tick marks here, what's going to go over here? 3 tick marks there, right? So why is QRT, that triangle in the middle, why is that isosceles? Well, because the legs are what? The same. So I can say, why is QRT isosceles? You would say the legs, Q to T, like me. What? Oh, okay. I thought something was amusing or funny.
No,
Okay. What's QT equal to, kids? RT. Therefore, if you have 2 legs that are congruent, what kind of triangle do you have? Isosceles, right? So that makes triangle QRT isosceles. Triangle QRT is going to be isosceles there. Okay? What do you guys think? This isn't too bad, I don't think. That last problem, that's a little tough. But do you have all the explanations written down in terms of how to handle something like that? Yay or nay? Okay. I'm going to send out your assignment right now. And I'm going to ask that you get started on this right away today. So make sure you're into big ideas. Not on phones and anything else in Chromebook, but get into the assignment and get started with this right away for me. Oh, where did I set my pen down? Anybody see where I set my pen down at? Help me out. Help me out. Help me out.
right there.
There it is. All right.